So my name is Michi, as you've heard. My presentation is on understanding philosophical devices and the role they play in AI. Now, there are quite a list of philosophical devices, from data sets, proofs, and but my focus is on a new set, which is games. So why games? Well, Plato once said you can discover more about a person in an hour of play than in an hour of conversation. And this was said hundreds of years ago, and I find that to be very true. If I need to know you better, it's much faster if we engaged in an activity with a win-lose situation. And that's the fastest way to analyze AI, to determine if there are any biases or anything, which is a logical error which probably cannot be seen in code. Now, another reason is games are fun, and if you're going to do something, at least let it be fun, right? So, one, it's worked for years. Games have been used to determine how smart kids are, where you're likely to fit in an organization, or what job you're likely to have. So, if you're trying to make artificial intelligence human-like, why not use human-like tests on AI as well? Lastly, games in general are sort of the unsung heroes for world problems. No one really looks at games and thinks there's a solution here for something critical. But in most cases, you find what you're trying to do has been done in games, and there are concepts which could be borrowed from that to actually improve on AI. Now, I just thought from yesterday when all the speakers were speaking, I felt that maybe I just had to add this last night, because I felt maybe we need to pay attention to what AI is and what AI is not. Now, computer programs, as I've indicated, are a list of instructions, like a recipe. But AI, as defined by John McCarthy, is every form of learning and intelligence that can be precisely described that a machine can simulate it and improve on it. So that's, for me, that's the key takeaway in terms of differentiating a computer program from an AI, which, again, you'd want to differentiate from a chatbot, which has a syntax that it follows in terms of answering your questions. That's why you'd go back to a chatbot and maybe it doesn't remember who you are. Again, it asks you, who are you? Because it's just answering questions. It has at least sort of a recipe. Now, a history of how AI has been developed to solve problems. It started off with brute force, which was, it had a list of different methods it would try until it would find the right successful one. So it computes very fast the different options and decides, okay, this is the best one. That's the option it gives you. We had the heuristics or rule of thumb, where the best likely path for success is what it would choose. Sometimes that would be wrong. We had the use of production systems come in. These production systems were used to now represent symbols in mathematical form, which was very crucial so that AI could now start to look at things even which are much more difficult to compute. Then finally, we are at the stage where now we are using neural networks. Now, on the other side, it's just how AI has had its role with games, how it's been tested. So in 1950, through brute force, it was able to win a game of checkers. And then in 1970, that was poker, thanks to production systems and heuristics. We move on to 1996, where Deep Blue, actually, and at this stage, Deep Blue was doing about 50 million moves per second. And Kasparov was just thinking on the fly, because at that stage in his career, he was one of the most unpredictable chess players. But in 1997, Kasparov had changed his playing style to be more structured. And so he lost. Actually, he considered defeat. He considered defeat to Deep Blue at a point where everyone thought he lost a good piece, but maybe he would have carried the game further, he would have won. At least other chess masters thought they would have continued the game better than he did. So in 2016, AlphaGo beat Lee Sedol. Now, AlphaGo was taught how to play by watching games of the game Go, which is a much more difficult game than chess because it has more options on the board. For each square has 4 moves, and then each subsequent square next to it again has the 4 minus 2, then 4 minus 2 above, but then again still has the overall 4. So brute force computing would not be an adequate method. So it focused mainly on neural networks. It had 48 of those looking at the different options. And so it beat him significantly. Now, where things got interesting is the AlphaZero. AlphaZero was another instance of AlphaGo that was trained by simply being given the rules of the game, and it played itself. After 40 days of playing itself, it went against AlphaGo and defeated it 100-0. By day 20, the game had gotten so good in this game that at the stage where it was decided no human could ever get that good in the game. At day 40, through itself teaching itself, it was able to defeat now what was at that time the champion of Go, which was its other variation. Now, for myself, I'm an avid video game player. And when I look at AI, as I play games and work on AI, I find a lot of issues with the biases in AI. Where guys I say, okay, the AI is biased, or the AI wasn't written properly, or had something. But in gaming, we actually thrive on these biases, and we find ways to tweak this. We know the biases are there, but they are tweaked to benefit the players who are playing. Now, just a quick game. Which of those two circles is large? A red one, by a show of hands. A blue one, by a show of hands. And the hands which didn't go up, is it that they are? Yeah, typically at the same size. What happens is just one is raised slightly higher than the other one. So perception really matters. So my next few slides, again, perception really matters. Now, this is a game called Arkham Knight, a game basically about Batman. Now, one thing, the good AI lets us cheat. Now, when you've written your AI programs and you want to avoid bias, and you want it to learn, but you know it's going to have a bias issue. For example, there was an AI that was supposed to identify dogs and wolves. It started identifying dogs as wolves, primarily because these dogs were in a field of snow. So when another AI was put in to figure out why this AI is making this wrong inference, the AI was looking at 20% of every image, because it had gotten used to seeing so many backgrounds of snow, which equaled always a wolf being there. It came up with its own inference. But in this case, you allow your AI to cheat. So in this case, you do let your AI learn, but there is something you've told it, sort of like a cheat code. By the way, this is sort of like racism. Why let AI learn racism when probably you could just teach it? So that's allowing your AI to cheat, and also to other forms of discrimination. So you give it a heads up. It doesn't have to learn everything on its own. You're also there to teach it. And now, good AI lets us know what it's thinking. Now, I find this is Far Cry 5. It's a game set in sort of pre-post-apocalyptic America. Now, when a lot of these game characters constantly talk to you, even if they are not there, through radio. So even your opponents, who is everybody on this screen right now, always communicate to you and tell you, I'm looking for you, I'm going to kill you, I'm going to attack your base, I know you are last seen here. Now, AI should also have this characteristic, because you want to know what your AI is doing at any one point. When you go back to your AI programs, and maybe your AI program is supposed to find a solution for world health and, let's say, food issues, you ask it, have you found the solution? And the answer should never be no. The answer should be not yet, but there's A, B, C, D sort of options I have, and I'm currently thinking about this, I'm taking this path. And that's where you come in and say, okay, no, that's not the right path. Because one path the AI might take, and it's valid in taking that path because you never told it how to value human life. Is like, okay, we are too lazy to get up and actually all go to the farm. I'll just get rid of half the population, and you keep up with the current food production system. It might also decide to do a mass relocation. So it'll just one day decide to move all the humans out of their way. So to avoid these unpredictable results from AI, have your AI always communicating to let you know what it's planning. Now, good AI is predictable. We understand that AI is built to solve problems. We want AI to solve problems which would take us forever to solve. You want to get these solutions as fast as possible, and these solutions are probably going to come from somewhere where we wouldn't expect them. But again, there has to be predictability in it. Now, this is a game called Halo 5 Guardians. What they've done here in the AI of your adversary is that your adversary, if you spook your adversary, they'll always run away. Now, that is predictable, but it's only predictable that they will run away. Where they run off to is not predictable, and that's quite important because you want your AI to be predictable enough for you to know that it's going somewhere, even if you don't know where exactly it's going to end up. By the way, it's able to communicate to you in the previous slide. It'll let you know, I'm heading this way, and this is the path I'm taking. Now, AI systems need to interact with us. Now, this is a series of games. The one at the corner is called Fear, First Encounter, Assault, and Recon. This was the first video game to actually have actual AI, not just programs, but AI where you played the game that looked at how you are playing the game and decided, okay, you like to go into cover and then attack. You like to scout your area before moving, or you like to go charging in guns blazing. And the AI talked to itself. So it talked to other characters in the game and fed them this information. So you'd walk into a room expecting 3 guys, there are 10. You walk into a room expecting guys with no shields, everyone's put up a shield because they talked. They were engaging not only with you, but with the system. The game below that is, I'm sure you've all seen this horror movie called Alien, or read the book Alien by Ridley Scott. So the green and the one at the far left, those are those 2 games. Now this is currently like the best AI that has been put in any game. And this AI has 2. They've copied what they did with Deep Blue, with AlphaGo. AlphaGo had 2 systems. That's why it could play itself. So this AI has 2 systems. One that knows exactly where you are at all times, but will never tell the main AI, the actor AI. So the director AI in this case is telling it, he's hiding somewhere in here, you go figure it out. So now the game actually could build for natural suspense moments, which my play session would be very different from yours. And the other 2 games, the second one is Fear. The third one is a game called The Last Guardian, where you have to interact with this AI character. You're the boy, you play with this giant winged cat-like thing. And it's afraid of glasses, but it'll protect you from guards. So you build a relationship where you get to a point you're stuck, the AI stops, and you take over, you break the glass, and the AI continues the journey. Now, that game best explains why we need AI to interact with our systems and with ourselves, because AI may change, because AI is supposed to improve on itself, so it's improving its algorithms. As it changes these algorithms, you want your AI to constantly interact with you. It's not changing its algorithm like it's some kid hiding in the corner and comes up with, okay, I've learned this, I've done this, let's move on. You want it to have that interaction with you so that it can, though some you may disagree with this, it may have a sense of consciousness. Consciousness is a sense of being aware, and we can assume as humans we have consciousness. And one might argue for the same that AI has consciousness, because people have argued in the past that even stones have consciousness. So why not AI? And if it does have, it needs to interact with us beyond just being a computer program. Now, AI reacts. Now, this is a game called The Phantom Pain. The Phantom Pain is just basically about this one guy who's badass and he serves the US Army. Now, what happens here is an enemy response system. What the game does is the game learns what you're doing. Whatever data you feed it while playing, which is now your playing style, it learns. So, all right. So as you move along, it detects, okay, fine, you're very good at headshots. We'll wear helmets. You like coming in at night. We'll put up floodlights. You're a sniper. So again, now instead of having the floodlights point in, we'll have them point out so that you can't see because the lights are blinding. Now, this brought into now our own uses of AI. You want your AI to react. If your AI was to detect a bias or to come across an anomaly, So data which is bad, for example, that for the wolves. The AI should have built within it some sense of questioning. Why am I getting only this? How can I improve? My tests have become easier. When the AI is only looking at 20% of an image, it's doing that much faster than looking at a whole image. So the AI is asking, why am I doing this fast? What's changed? How do I better? Have I gotten better, or has the data gotten bad? Next, good AI has its own goals. Now, this is a game from those who love the Lord of the Rings books. This is a game based off of those books. It's called The Shadow of Mordor. Now, the characters in this game have one thing which I had mentioned earlier, that the chatbots never remember you. Every character you meet in this game is uniquely built and remembers you, and remembers not just your name. That will just assume there's a trigger built to save your name somewhere. It remembers the very interaction you had. Character would remember, you cut off my arm, or you killed so-and-so there and here, or such things. And the characters have, characters have their own ambitions within this game. They're interacting within your world, but they have goals to either ascend. Someone at this corner there, you can see they're trying to ascend to a certain level up their ranks, so to be a general, maybe to be a sergeant. And what we need with our own AI, as much as you've given the goal of AI is to find a water shortage issue, you should allow your AI an ability to create its own goal. Because we can't treat biases with technology. We only treat them through design. So design it to be more human-like. Yeah, that's that. And from yesterday's, another takeaway I got from yesterday was when guys were talking about all the smart cities, and I wish they had played this game. Minimetro is a small game that allows you to randomly build tube stations and railway lines as random points which are treated as stations appear across your city. You can play across about 50 cities in the world. Each has over 2,000 variations that could occur. I wish they had played this when we were building all these smart cities. Even better when the ideas of these smart cities were coming out and you're saying these smart cities are going to be AI-driven. Why can they be AI-driven like this? Why not build AI that designs cities for you, that designs your next smart city for you? Instead of building the infrastructure and hoping they come, let the AI build based off of everything it has and even tells you how you'll achieve this smart city. Otherwise, we end up with smart cities we've been waiting for 10 years. The one on my far left is SimCity, which builds modern cities. Everything you'd want from a city in the year 2000 to the year 3000. The one on my far right is called Zeus, where you build ancient cities either in the Greek time or the Egyptian time. I guess I can take 2 questions.
Any questions? Do we have any questions from the audience? There.
Now, it's been a little scary hearing from you that a machine can be taught how to play a game. Now, my question is, where we sit in a place where client confidentiality is very important. Nowadays, when you log on to a website and you want to download something, you actually see a captcha and they tell you, can you see store doors or bicycles, etc. Does that mean that AI will kill the captcha?
Yes, at some point it will. Because what all this AI is, for example, the one for the dog, it's been trained to see a dog in any images. It's trying to draw a dog, so outlines of the different dogs it's seen. It doesn't see a dog there. It tries to look for eyes, faces. The same way when you're taking a picture of yourself, the camera identifies your face. It's looking for a face-like structure because it knows I should see 2 eyes, a nose, a mouth. But how you've explained the nose and the mouth to it is like you've explained there are 2 points, average this far distance apart or more. There's a nose, there's then another opening below that nose, that will be the mouth. You should see two things at the back. That's typically how you'd build the base of your facial recognition. So recapture at a point, yes, will become obsolete. There are AIs which are being trained to pick. What has happened is that now you're having more blurrier images being put in. But now AIs are being created to render images into 4K that were at 240p. So if you have an AI that has that capability, both capabilities, which is that would be now artificial general intelligence, and it's able to transcend two different fields of knowledge with one set of knowledge. The same way you assume a chef knows how to cook, but he can still kill you. Yeah. What would be the
mitigation plan?
You
Capture dies. Say capture dies, yeah?
Yeah.
What then becomes the mitigation plan?
They have to. I haven't thought of what they would do if that happens. As they close down that business and look for another business line. Any other questions?
Any other questions? Okay. Thank you very much, Michael.